Good morning, everybody. How are you? I hope things are going great. So, listen, the first thing we're going to need to do is to go over the answers to the previous homework. And most unfortunately, I literally tonight ran out of paper for my printer, so I have to read you the answers. And then if you have any questions, you can talk to someone or contact me. Number 1 is 22. Number 2 is 85. Number 3, x minus 5 times x plus 4. Of course, they're binomials in parentheses, as will all of these be. Number 4, x plus 7, or x plus 7 squared. Number 5, 3x minus 2 times x minus 2. Number 6, 2x plus 17, 2x minus 17. Number 7, it says factor completely, so that always means 2 or more, almost always 2, but sometimes more steps. That's 4 times x squared plus x minus 2, which further factors into 4 times x plus 2 times x minus 1. Number 8 is 4. Number 9, negative 3.1 or 1.6. Number 10, inverse functions, y equals x plus 15 over 5. Number 11, y equals the square root of x plus 7 over 9. Number 12 is 37. Number 13 is 52. 14 is 2x squared plus 7. 15a, 1 over 243, b, 1 over 343, c, 64, and d, 1 over 64. I just want to emphasize that the difference between c and d is the negative in the exponent, and negative just means reciprocal, 1 over. Number 16 is 65. 17, it's choice 1. I put that question on there just so that you knew that if you ever get a question like that, all you need to do is graph each one in the calculator, and whichever one looks like it. Actually, I think it might actually be a different choice. Let me see here. Let me look. I just had an idea that it could be a different choice. Vertical shift brings it up to. Yes, okay, correct. 1 is correct. I thought I might have made a sloppy mistake there. Number 18 is choice 2. And if you had difficulty with this, it's in an upcoming lesson. It's a slide that we go over. So if that one bothers you, don't let it. We will go over it in detail at a later point in time. Okay, so those are homework answers. Now you get to work on the pregame stretch. And as we know, with these pregame stretches, I don't know what your pace is going to be. This is very individualized. So do stop and start, do the questions, and then continue until you're done, and then I'll show you the answers. So go ahead. Stop and start time. And that's it. Okay, so I assume that you have now finished these with all of your stop and starts. Here are the correct answers. Again, stop and start. If you have any questions about them, you can talk to a classmate or email me. Set up office hours. Remember, always email me first for office hours. And I actually think for the pregame stretch that there's a second sheet in here. Answers 2, yep. Okay, so one question I would like to talk a little bit about, I believe it's on here. No, it's not. Okay, it's coming up a little bit later on. All right, so though it's the pregame stretch, it's also the homework answers. Listen, that's everything that we do is important. But we have a test coming up next week, all right? For this week's purposes, we have a new lesson today, a new lesson Wednesday, a quiz Wednesday. Next week, pre-test Monday, test Wednesday. Following week, we have Regents Review. or Regents. That's years ago. We have final exam review the following week. We'll do review on Monday and review on Wednesday. And then your final exam is Monday, the 12th of December at the following time. So the pregame stretches that you have today and Wednesday will not only be similar to the quiz that you take Wednesday, but it's also going to be similar to a number of questions that you have on your final exam and on your third test. So these are particularly important ones. And if you're struggling on these, you need to make sure that you find out what you're doing wrong and how to correct it. Okay? All right. So next up is our lesson for today. So slideshow, and we'll do the first half of it now. I was up in Pulaski, New York, fishing with my buddy streamside on the Salmon River, and this hawk just flew and landed in a tree maybe 20 feet from us, and he just stayed there. He wasn't spooked by our presence. At the moment I was relaxing streamside, I wasn't even fishing, and I got up, very slowly got my camera out, walked up, got good angles on him, and I actually walked probably about 270 degrees all the way around him in an attempt to get good picture angles. And this was a little bit cluttered, but I did get some better picture angles, which I'll probably show you another day. Okay, so this week we're going to get into logarithms for the first time, and it's the last topic that we're going to cover in the course. We already did the homework review. We've done the pregame stretch. Now recent work recap. First question up, if 3x is one factor of 3x squared minus 9x, what is the other? You know, we're doing stop and start here. Okay, so the other is x minus 3. And you can tell because if you, first off, just factor 3x squared minus 9x, take out the common factor of 3x, you're left with x minus 3. But if for some reason you weren't comfortable with that, you could just distribute 3x times each of the four choices, and only one of them will get you 3x squared minus 9x. Okay, just distribute back to check. That's all you got to do. Okay, go ahead, we'll factor in here. Okay, a little difference of two perfect squares review. Difference of two perfect squares features out number 3, 7x minus 6 times 7x plus 6. Should you ever get questions like this on multiple choice, if the factoring, which is the quickest way to do it, is not immediately apparent to you, then you can simply distribute back, double distribute back, and see which one gives you the answer you're looking for. Okay, solve for all values of x. Go ahead. Okay, so we're cross multiplying here, and we get x times x plus 1 is equal to 90. Get everything on one side. X squared plus x minus 90 is 0. Factor x plus 10 times x minus 9. Subtract 10 from both sides, add 9. And there's the correct answers. Okay, write the inverse function. Y equals 3x plus 24 and y equals 3x squared minus 8. Go ahead. Now, the key to understanding inverse functions is that it reverses the function, so to speak. The input becomes the output, and the output becomes the input. So when I see y equals 3x plus 24, the first thing I have to do to figure out what the inverse function is switch the x and y, which I do. Now I just solve for y. Subtracting 24, dividing by 3, and sometimes they'll leave the answer y equals x minus 24 over 3, and sometimes they'll write y equals x over 3 minus 8. For the next one, again, just like before, switch the x and y, then solve for y. Add 8, divide by 3, square root both sides. Y, the square root of y squared is just y, so you get y equals the square root of x plus 8 over 3. Okay. Little basic function evaluation kind of questions. Go ahead. Remember, I did speak to you about how I felt the best way to do something like this when they're asking for multiple values from one particular function is to put it into y equals. First one might be so easy for you, you can just do them off the top of your head. The second one, it might help you to use the calculator, whichever way you prefer. Okay, so Let's hope I got these right. I tend to make mistakes on these. All right, so the first one, 7 times 5 minus 4, which is 31. Then 7 times negative 5 minus 4, which is negative 39. And then 7 times 20 minus 4, which is 136. Woo woo, I got those right. No sloppy mistakes on my part yet today. Next up, 3 times 4 squared plus 4, which is 3 times 16 plus 4. I should have made this a plus, but I did do plus in my head and got 52. So ultimately, it's okay. I just did a little bit of a boo-boo in my work being shown. Next up, 3 times 8 squared plus 8, which is 3 times 64 plus 8, which is 180, and 12 is 192, and 8 is 200. Remember, this function g means take whatever the input is, square it, multiply it by 3, and then add that original input back in. That's why in the F one, it said minus 4, so everything says minus 4. But in this one, it says plus the input. So in the first one, the input was 4. Remember, that should have said plus. For the second one, it was 8, and for the third one, it's going to work out to be negative 5. So 3 times negative 5 squared is 3 times 25, or 75, minus the 5, which is like plus the negative 5, gives you 70. So I actually got all of those right. Woot woot. All right, I promised you we were going to go over this one at some particular point in time, so here we go. Since you already did it on your homework, let me explain why the answer is choice 4. Because the range is the y values. This is the y-axis. The lowest y value is right here. The highest y value is right here. That's pretty obvious. The highest y value is 70. I would have thought the lowest y value was 55, but the closest thing they've got is 56. If you notice the difference between choices 2 and 4, choice 2, it's an x. Choice 4, it's a y. Range or output is always y. That's why it's choice 4. Okay, go ahead. Okay, so f of 4, I give a 4 to f. It takes whatever I give it. It takes that input, multiplies it by 3 to make 12, plus 2 is 14. And then, remember, since it's g of f of 4, after I find f of 4 and I get that output, it becomes the input for g. 14 squared is 196. Now let's see if it's commutative. That is to say, if the order matters. So if I find g of 4, I get 16. Because g just squares what you give it, the input. And then that output of 16 becomes the input for f. 3 times 16 is 48, plus 2 is 50. Notice they're not equal. So composition is not commutative. All right, this will show you exactly why. Because f of x is 3x plus 2, and then I have to take that output and give it to g. So remember, when we're doing these, we're taking the specific value of x. So f of x is 3x plus 2. Then I give that 3x plus 2 to g, which squares whatever I give it. The input was 3x plus 2, so 3x plus 2 squared means 3x plus 2 times 3x plus 2, which is 9x squared plus 12x plus 4. F of g of x is x squared. F of that is 3 times x squared plus 2, so it's just 3x squared plus 2. Okay? Next up. Radical equations, remember, isolate and square. Go ahead. Another few seconds or so. Okay, so first case, isolate the radicals, subtract 5 from both sides. So that gives me the square root of 3x minus 3 is 6. Square both sides. That would give me 3x minus 3 is 36. And then add 3, divide by 3, and I get 13. For the next one, it's already isolated, so I just square both sides. I forgot to put the squared there, but it's here. So x squared is 3x plus 28. Get it all on one side. X squared minus 3x minus 28, because when you subtract it, is 0. Factor, x minus 7x plus 4. and I get x equals 7 and possibly x equals -4, but when I go to check it, I realize it doesn't check because the square root's never negative unless the notation says so. So that means that it's what we call an extraneous root. Okay, go ahead. Okay, squaring both sides. I get x minus 4 is 7 squared. So x minus 4 is 49. Adding 4, and I get x is equal to 53. So I am, at this point in my life, I am 59 and a half years old. And blood pressure medication becomes a pretty common thing for people my age. And that little alarm you hear going off is my reminder to go take my blood pressure meds, which I will do in a couple of minutes, but not until we're done with this video. Okay, so let's give this one a try. Go ahead. Another couple of seconds. Okay, so remember we read it backwards. So first we give the function to g. I get 9 squared minus 1, which is 80. Then I give that 80 to f. 3 times 80 plus 1 is 241. Okay, a little negative and fractional exponents. This is the explanation as to why they are what they are. I'm just keeping these the same. Let's have you try 3 to the negative third, 12 to the negative 2, and 5 halves to the negative 2. Go ahead, give it a shot. Okay, so 3 to the negative 3, negative exponent means reciprocal. So that's 1 over 3 to the 3, and that becomes 1 over 27. 12 to the negative 2 similarly is 1 over 12 to the 2, which is 1 over 12 squared, which is 1 over 144. And keep in mind that this means reciprocal. Oh, here, ding, ding, ding. Here's my linguist daily dumb mistake. All right, so there's my negative exponent. I did not take the reciprocal, so I'm going to go through something like this. So this is 2 and 5. This is 2 and 5. And this is 4 and 25. And let's go to play from current slide. And let's hope this is all looking out very, very good. Okay, so first one, second one we went over. Here's your third one corrected. Negative exponent means reciprocal. So the 2 has to go into the numerator and the 5 into the denominator. 2 squared is 4, 5 squared 25. Now, fractional exponents. Remember, the roots of the tree are down. The power is in the leaves. So we want to take the root first and then the power because the numbers are smaller and easier to work with. For instance, if I do the cube root of 8, I get 2. And then I square that to get 4. That's the quickest way to do it. And here's some ones to practice on. Go ahead. Little stop and start moment here. Okay. Okay. So they want to know what's the value when x is 6, so I substitute a 6 for all the x's. That's 9 to the 1/2 plus 3 to the 0 plus 8 to the negative 2/3. So 1/2 means the roots of the tree are down. It's the square root, and with a 1 power up top, it just stays the square root. So 9 to the 1/2 is 3. Anything to the 0 is 1. And then negative exponent, 1 over the cube root of 8 squared. Cube root of 8 is 2, squared is 4. So I get 3 plus 1, which is 4, plus 1/4. So it's 4 and 1/4. Go ahead. So remember on these guys that we're going to raise both sides to the same power to get rid of this exponent on the variable, and it's always the reciprocal. So I'm going to raise both sides to the third power. When I do that, I get x is 19,763. If for any reason you're doubting that answer, because it does seem pretty large, you could go on your calculator and type in 19,683, up arrow or caret symbol, and then type in 1/3, and you'll see it comes out to 27. So that's a way of checking it. Okay, which number is the largest? Go ahead. Okay, so a negative exponent, reciprocal. So since it's to the first power, it's just 4. Number 2, anything except 0 to the 0 power is 1. Half means square root, so the square root of a fourth is a half. And square 1/4, it's 1/16. What's the largest one? Choice 1. Next up, solve algebraically. Very important when you do this that you get a common base. Go ahead. Okay, so my common base is 3. 27 is 3 to the third. 9 is 3 squared. When I raise a power to a power, I multiply, so that's 3 to the 3x and 3 to the 2x plus 4. Once I establish that the bases are the same, then the exponents have to be the same. So 3x is 2x plus 4, x is equal to 4, subtracting the 2x from both sides. Okay, so we've gone through a lot of recent material here, and if you're able to get all of this right, you're looking really, really good. If not, don't panic. We've got today, we've got tomorrow, we've got Wednesday, and then next week as well on Monday before you have a real test on it. Okay, next up, speaking of getting common bases and working the problems out, just in case you had a little bit of problems on the last one, let's do 4 more of these. We'll do them one at a time. So do number 7, stop and start, then 8, then 9, then 10. Go ahead. Okay, so for number 7, the common base is 5. So I get 5 to the 3x plus 1 equals 5 squared, because that's what 25 is, to the 2x plus 1. And remember, when we raise a power to a power, we multiply. So this right-hand exponent becomes 2x plus 2. The bases are now the same, so the exponents have to be the same. 3x plus 1 equals 2x plus 2. X is 1. Try number 8. Go ahead. Okay, so big question. The hardest part of this, what's the common base? Common base is 2. So 4 is 2 squared, and 2 is already in its base form. So distributing the 2 times negative x plus 1, I get 2 to the negative 2x plus 2 equals 2 to the 2x. So the exponents have to be equal. Negative 2x plus 2 is equal to 2x. Adding the 2x to both sides, I get 2 equals 4x. Dividing by 4, x is a half. Okay. Next one up. A little tricky. Oh, man, I can't believe I did that. I didn't mean to. Well, you got the first step to start yourself out with here. Okay, so 2 to the a is a to the 2a equals a to the a plus 2. Once you've got 8 as the common base, make the exponents equal. A equals 2. And the last one, go ahead. Okay, common base is 2. 16 is 2 to the 4th. Distributing that 4 to the m plus 7. And I get 2 to the m plus 1 equals 2 to the 4m plus 28. Get it all together. Since the bases are equal, exponents are equal. And I get 3m is equal to negative 27, m is negative 9. So that alarm, I guess this time, means it's not only time to finish that particular question, but it is time to take my blood pressure meds, and it's time for me to end the video. All right, we'll be back with another video in a few minutes.